everyone! Today we are going to go over how to graph sine and cosine. Alright, so before we get to graphing, we're going to actually find coordinate points to graph, and we're going to use the unit circle to help us. Alright, so first off, when we graph sine and cosine or trig functions in general, typically we use radians. You can use degrees, but it's just more common to use radians. So I'm going to go ahead and pull up the unit circle. And here, our x value is negative 2 pi. All right, so really, in reality, we should be able to fill this in based on our knowledge of how sine and cosine work and the unit circle. So if we look at negative 2 pi, right, if we look at the unit circle here, our sine value at negative 2 pi is going to be 0. Then if we look at our sine value at negative 3 pi over 2, all right, negative 3 pi over 2, our sine value is going to be 1. At negative pi, our sine value is going to be 0. And at negative pi over 2, our sine value is going to be negative 1. And keep in mind, these sine values are the x values of the coordinates at these locations. Then we have sine of 0, which is 0. We have sine of 1/2, or not 1/2, pi over 2, which is 1. We've got sine of pi, which is 0, sine of 3 pi over 2, which is negative 1, and sine of 2 pi, which is 0. All right, so basically we just got a bunch of zeros, ones, and negative ones. So when we go ahead and graph this, we are going to have this be our 0 mark, all right? And then let's go 1, 2, 3. So we're going to put negative. This is going to be our negative pi over 2. And then our pi, negative 3 pi over 2, and negative 2 pi. And same thing over here, pi over 2, pi, 3 pi over 2, and 2 pi. And you can see our y-axis is already labeled as 1, 2, 3, like typical. So then we can go ahead and actually graph this now. So our first point is negative pi over 2 and 0, or negative 2 pi and 0, so we plot that. Then we're going to go to negative 3 pi over 2, and that is at 1. Negative pi is at 0. Negative pi over 2 is at negative 1. 0 is at 0. Pi over 2 is at 1. Pi is at 0, 3 pi over 2 is at negative 1, and 2 pi is at 0. All right, now, just from looking at it, you might, and don't copy down what I'm about to draw, it kind of looks like a zigzag, right? However, it is not a zigzag. It actually has a lot of curve to it. So let's go ahead. I'm going to actually graph this, or show you what the graph looks like here. If we have sine of x, you can see that it's very curvy, right? So when we graph this, we need to make it, it's like a half circle, and then another half circle, a half circle, and then another half circle. So that's what the graph of sine looks like, all right? Now let's go ahead, we're gonna try and do the graph of cosine. All right, so first, of course, we gotta go fill in these values. So we've got negative 2 pi, it's gonna be 1, negative 3 pi over 2, 0, negative pi, negative 1, negative pi over 2 is going to be 0, 0, 1. And again, these are all just coming from the unit circle here. And then we've got pi over 2, which is going to be 0. Pi is negative 1, 3 pi over 2 is 0, and 2 pi is, again, 1. All right, so again, we're just going to label our x-axis with these values that we have. So that is going to be negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. Then we've got pi over 2, pi, 3 pi over 2, and 2 pi. All right, and then we're just going to plot those values that we have. So we've got negative 2 pi and 1, negative 3 pi over 2 and 0, negative pi and negative 1, negative pi over 2 and 0, 0, 1, pi over 2 and 0, pi and -1, 3 pi over 2 and 0, and 2 pi and 1. All right, so now let's take a look at what the actual graph of cosine looks like when we graph it. It looks like this. So very similar to sine, it's just kind of shifted. I'll put them on the same graph so you guys can see what they look like together. The red one is sine, blue one is cosine. So again, we graph them like half circles. So that guy starts there, half circle there, half circle there, half circle there, and that. All right. So that is the graph of cosine. All right. So as you guys learned in Math 1 and Math 2 and Math 3, you can do transformations on graphs to make them skinnier, to make them kind of fatter, to shift them up and down. So that's what we're going to do with these graphs here. So let's go ahead and take a look. These first couple ones, I'm actually going to make a little bit easier, just because they've got two transformations going on. I don't like that for our first couple of problems. So let's just, for this one, erase the -1. Cool? So let's pretend it's just 4 sine of theta. So if you recall, all right, when you put a 4 or a number, when the absolute value is greater than 1 out in front of a function, it's going to kind of stretch it and make it bigger. So first off, let's think, okay, normal sine, right? If we look back at this graph here, it goes like this. We start off at 0. All right, and it would look, oops, it wasn't perfect, but all right. It would look something like this, all right? Now, if we put a 4 out in front of it, what's going to happen is all of our y values are going to be multiplied by 4. So 0 times 4 is still 0, so that guy's going to stay there, right? But our 1 is going to become a 4. Our 0 is going to stay at 0. Our -1 is going to become a -4, all right? So this is what this graph is going to look like. And you actually can continue. You can see how the pattern looks here, right? So the blue graph here is the actual correct answer of how this graph should look, all right? So that 4 just stretches it. Now we can go ahead and, of course, just check our answer here. I'm going to keep regular sine as red, and let's see what 4 times sine of x looks like here. As you can see, it looks just like what we got. It's going to stretch up to 4 and go down to -4. All right, so the next kind we have to know how to do is when we actually shift the function up or down. We do that by adding or subtracting a number on the outside here. So we know that normal cosine, right, is going to go here, 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 and here, right? We know that from the graph that we did at the beginning of this video. So what ends up happening then, when we have that minus, is it's going to shift all of the y values down. So typically, cosine and sine, for that matter, have kind of a baseline here at 0. And if we're going to shift it down 1, our new baseline is going to be right here, all right? And everything is just going to shift down by 1 unit. All right, and this would be our new graph here. All right. And of course, the only one we really care about now is the blue one, because that is our actual correct graph for the given function. All right. Now let's do one where we're kind of doing 2 transformations. All right. So how about let's take a look here at number 3. We are first shifting, well, first I guess I'll draw the parent function of cosine, which looks like this. All right, and remember to make your function look curvy, not like a zigzag. Then we're going to go ahead and shift it up by 2. And the 1/2 is going to compress it. So instead of going like up 1 and then down 1, we're actually going to go up 1/2, go to our baseline, down 1/2. Up 1/2, baseline, down 1/2. And our function is just like a little bit kind of smushed, right? And that's what that guy would look like.